Okay, so after the 10,000 square, or in line with the 10,000 square, are what are called number disks. And the thing about number disks that are different than either the 10,000 square or base 10 blocks is that base 10 blocks and the 10,000 square are what are called proportional manipulatives, which means there is a relationship of the size as related to the number. So like 10 is physically 10 times bigger than a 1, 100 is 10 times bigger than a 10, 1,000, blah, 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 right? So the trick is here we're going to use non-proportional manipulatives because see the discs are the same size no matter, it's the value written on them that gives them value. So this is like a higher order thinking skill than the other one. Now the kids have to understand that things can have different values. So these are all clones, so you can practice doing things like this. What number do I have? 1,000. What about now? 1,100. What about now? 1,200. What about now? 1,300. Now this is where it gets tricky. 1,310, 1,320. Now normally we progress in that order and we get smaller each time, but it's important to do it like this sometimes too. So we have 1,320. What if I brought out another 100? Well, now it's 1,420. What about if I bring out a 10? It's now 1,400, not 20, but 1,430. 1,431, 1,441, 1,442. What about now? 2,442. So these are the kind of things like teachers are often surprised that kids have trouble doing it out of order like this. That some kids are good if you do the yellows, then the orange, then the red, then the white. But we need to be able to do it in any order and adding any one at any time. That's real understanding. So that's something that you start out with just like, orange, red, and white, and then you make sure they can do them. If they can't, you probably would go back to the 100 chart and practice what adding a 10 on to something does and help them understand that. Then come back here. No, then I would probably go on to the 10,000 square and draw out numbers on there. And like if I had 2 X boxes and 3 rods, it would be 230. And then if I put another X box on, it would be 330. And another X box would make it 430. So their kids can see the size difference there. And then eventually we bring them back here and we get into just worrying about numbers without the size of the manipulative. Then on the next screen, I did even larger numbers. So these are in color with the discs that I generally use. The ones are white, the reds are 10, and orange is 100. I think the 1,000 is yellow, but I'm not sure. And then I don't even have ones with 10,000, 100,000, or a million right now, but I made up separate colors so you can see that basically we just want kids to know that it's the color that gives them value now, not the size. I'm going to add in some of these activities that I do with the kids. I think I don't have a name for this game, but I'm going to call it Guess Again. So I would start out with the kids and say, all right, I'm going to ask you to write a 3-digit number. And I would ask them, what's the largest number you could possibly write? And I get them to eventually tell me that it's 999. Then I ask them the smallest number, which really could be 000. 001, but you have to have a number on each line. So I guess 000 is the smallest. So I say, pick a number and guess. And then I know the answer. I think it's 312. Let me look. Yeah. So I ask them the number to write a number down on their communicator with their partner. And then I look around. I had them hold it up. And I say, wow, you all did great. You all got a 3-digit number, but no one ever has 312. So I say, but you're all wrong. Ha, 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 ha. Let's try again. So then I give them a hint. The number's greater than 300, but smaller than 400. So I wait to see them all guess again. As long as they have 300 something, I'm happy. If they have 200 or 99 or smaller or 401 or smaller, then they don't really understand very much about place value. And I might want to not do this with certain kids. I would want to go back to my 100 chart or my dumbbell or my 10,000 square because they don't understand. But for kids who do, as long as they have a 300 number, we're good. Usually nobody still has 312. If they do, I say, put it down real fast. And I tell them not to show anyone else because other people need more hints. So then I give them a next hint. The tens digit is smaller than the hundreds. Well, we know the hundreds has to be a 3. So then the tens is either a 2, a 1, or a 0. So we're talking like 3, 1 something, 3, 0 something, 3, 2 something, or 3, 1 something. Let me say that again. That was confusing. 3, 20 something, 3 something in the teens, or 3, 0 something. So they guess. Again, if they have 312, I tell them to put it down, don't show anybody, but generally they're still not getting it. Then I say the sum of the tens and the hundreds is equal to 4. So that narrows it down even more. If the hundreds is 3 and the sum of the hundreds and the tens is 4, that means the tens has to be 1. So now we're talking it's 3, 1 something. Could be 3, 1, 0, like 310, 311, all the way up to 319. So then they guess again. And then I say the ones is 1 smaller than the hundreds. So this should give it away. If the hundreds is 3 and the ones is 1 smaller than that, then the ones should be a 2, which ends us up at 312, which is 312. But every once in a while I get some kids that don't know, so then I give them one last clue, and I say it's between 311 and 313, and that pretty much hopefully gives it away, 312. So this activity is called Guess Again. It could be made to be numbers, 2-digit numbers here, 3-digit, 4-digit, 5-digit. I will try to make more of these for people, but I'm hoping that some people can see what I'm doing here and be like, oh, I could do that. That's not that hard, which pretty much anything Harry does is not really that hard. So that's the idea. Let's, okay, I'm going to try to squish this on the video too. This is another thing I do where I don't have a name for this either. Let's call it jumble. You'll see why I call it jumble in a minute. So I got the numbers 1, 2, 3, 4, 5, 6. I slide it down and I say to the kids, arrange the numbers to make the largest number, which for you and I is easy. 654,321, 654,321. Not quite as easy for some kids, but it does give you a very quick insight into their level of understanding. Of course, you don't need 6 numbers. You could have 5 or 4 or 3, and they could be different numbers. It doesn't matter. But then I have them do things like this. Arrange the numbers to make the number closest to 200,000. So the idea is you're going to start with a 2 for 200,000, then you want it to be as small as possible to be close. So the answer is 213, 456. This one closest to 500 is either going to be a low 500,000 number or a high 400,000. I think it's 512, 346. And then this one's a little harder, 250. So where are we going to be? So I think it's like if there was a 9, it could be 249 something, but there's not a 9. So it's 251 something small. 251, 346. Yeah, I think that's the answer. So this is called jumble, and these can be made at all different levels as well. Let's end this video before